All right, welcome to this presentation. I'm going to kick us off here. So this is essentially in continuation of last year's presentation, where I was addressing the question whether there's a place for Samba in the era of the container platform. And essentially last year, we embarked on a journey and heading out for new shores. And this year we want to give a little report and see how the journey continued and where we are heading today. So I've brought with me John Mulligan, my colleague from Red Hat, and we are collaborating on these things. Anything else to add, John?
No, let's get into it.
All right, so then let's go to the next slide, please. Right, this is a quick update. The updates, a little bit what has happened, details about the operator with a nice demo, and then a little bit the outlook of what are the plans and possibilities for the future. So without further ado, let's get into it. All right, a brief look back. Right, last year I was introducing Kubernetes concepts, Kubernetes being the container application platform, a cluster of Linux hosts usually that allows you to manage and deploy, manage those containerized applications. And as part of our work in Red Hat, we've been engaged with storage aspects of this technology since quite a while. And I've personally been struggling a while, fighting the good fight to bring relevance for Samba into this new ecosystem where initially there's no obvious way, right? And so what I demonstrated last year is when I started to experiment with this, and I showed a prototype, so-called operator, which is a piece of software that manages your application. And in this case, it manages Samba installations. And we had two so-called custom resources, which is kind of types in Kubernetes. One is an SMB service type that is essentially taking an existing piece of storage and putting a Samba on top of it to serve this out as a share. And the other is a SMB PVC, where PVC stands for persistent volume claim, which is kind of a Samba service together with a tightly bundled storage volume. So this is what we showed what I demonstrated and explained last year. This year, we are going to show where we are getting. And just a disclaimer before we move on. While this is all motivated and driven by what we're doing in Red Hat, purely as open source, it is kind of presenting raw technology, the state where we are. It is not any opinion of Red Hat or anything. It's us as technologists presenting these things here. So we can move on to the next slide. And so I'm not going to go into this. This is just a couple of pieces of terminology that we'll be freely using. Many of them have been introduced last year. So those interested might go back to the archive of sambaXP and watch the recording from last year and or ask offline in the chat or later on. So we'll be using them. And with that, we're going to continue and see what has happened since last year. So first of all, the intended use cases. Right. Last year, I mentioned two possible use cases for Samba in the container platform. The first is we have been starting to work on technologies where we are actually managing virtual machines running in containers and managed with the same tools with which we're managing the containerized applications. And when you're running Windows VMs there, which is kind of one of the major purposes of running VMs on Linux systems, then SMB is the natural choice for attaching shared storage to those. So Samba would come naturally into this. A newer thing that I also mentioned last year is that is becoming more popular in the recent days is Windows workers. So you can build and run containers on the Windows operating system. Kubernetes is a Linux thing though, but recently capabilities have been added to add worker nodes. So this is not the control plane. This is not the master nodes, but worker nodes that can run container applications that are based on the Windows operating system. And even here, if you want to consume storage from the Linux side of things, where we, for instance, are running our storage services, you need to go with the network. And yet, again, SMB comes up as a natural choice. A new thing has gained a lot of attention recently, which is NAS users. So we want to use the Kubernetes platform and our storage services running in it to provide storage for clients running outside of Kubernetes, clients that are not running in containers in Kubernetes itself. So that's kind of the NAS use case, like Windows environments. And instead of the traditional monolithic Samba server cluster, you could go and say, why can't I use Kubernetes as the clustered operating system to host my Samba services? This has recently gained a lot of interest, and this is also what has triggered our recent efforts around this even more than they were before. So that's the introduction for the use cases, and now let's see where we are. So, as mentioned, the NAS file is one of the focus areas today. And since roughly last year, October timeframe, we have started doing more work on this. And this is when John joined, and the whole work on this operator prototype has been taken to new dimensions. So we were basically concentrating on low-hanging fruit. We were bringing the basic functionality up first, and not doing any special integration with special backend storage systems, not caring much for performance, but make it work first, and make it work the way you would manage and you would do it in the Kubernetes environment, focusing on declarative workflows, just supporting a few basic customizations. In our operator-driven world, a lot of stuff we do is opinionated, kind of. You bring the thing up, but you don't unlock the whole flexibility, what, for instance, in this case, Samba can offer. We bring a kind of higher level configuration that John will be explaining in a bit. And we have been focusing on this, getting the right types for the management and Active Directory support. You want to, of course, be able to join Active Directory and so on. John and a few others have started looking into this and helping with the projects. And we have established like a real organization ecosystem around it. So we have created, from my personal repos, we have created a whole organization, Samba in Kubernetes, or called Sync, just as the working title. And we have created a container registry organization on the Quay registry, which we created, we own, we can add other people. So this is a potential place for future additional containers for Samba to be hosted. When I say ecosystem, I also mean it's not just the Git repo. We have established the whole flows. Each pull request is going to be tested in Kubernetes, actually. After it's merged, images are built and then published. So after each PR, we get images updated there, and they can be pulled and tested in independent scenarios. So quick side note, like why GitHub? The Samba community will probably ask, well, it's just the whole Kubernetes operator ecosystem is all centered in GitHub. It's what we're using almost exclusively in our day-to-day work. We're just used to it. And to be very honest, especially with the recent addition of the extremely powerful GitHub Actions, the CI was just super trivial to set up. So this is what we were doing. It doesn't need to be the last word, but it's where it currently is. It's fully meant to be an ecosystem and an environment for the Samba team. It's not meant to be just ours. So I will send more information email to the Samba technical list to give the broader public an introduction after this presentation. So, and with that, my introductory words are coming to an end, and I will let John do all the hard work with the details and the nice demo. Over to you, John.
Thank you, Michael. I really appreciate that. So as Michael mentioned, we have our overall GitHub organization. And under that, we currently have 3 projects. The first one is the Samba Operator. That's the marquee project. That's what we'll be focused on today. But it doesn't really do anything without the other 2. The operator itself deals with Kubernetes directly, and in fact is the only part of the system that deals with Kubernetes directly. It watches resources within the Kubernetes environment, makes changes to Kubernetes environments. That's a little bit of a tongue twister. The Samba container itself is a project which builds container images. These container images are what contain Samba things. the various binaries, tools, scripts, config files, things like that. That repo creates 3 artifacts. We have a file server, we have a client that's based on SMB client, primarily used for test, as well as an ADDC server image, which is currently testing only, as it is configured with a static configuration currently. Lastly, we have a small project called Samba CC. The CC stands for Container Config. This is a library and a script. And if you're familiar with containers, that is our entry point script. And what it does is acts to ease the transition between the outside world of containers to the inside world of Samba. This is a Python-based library, and it's pretty young. So this is a more visual representation of what I just spoke about. Up top, the first box is the Samba operator. When running in Kubernetes, that runs as its own container image. And then it is responsible for spawning and creating instances of Samba containers. Again, Samba CC is the mediating layer between the container space and the rest of the system, where we have long-running binaries like SMBD and winbind, various tools like the net command, SMB status, things like that, as well as the various system tools and configuration files, primarily etc password, NS switch, things like that. All right, so if you poke around the Kubernetes space, you'll probably see the term cloud native floating around. To me, that's more of a general term describing Kubernetes and things around it, the general wider ecosystem. So how do we want to fit into this environment? Well, clearly we have to use YAML. Lots and lots of YAML. And some JSON too. All right, silly little joke, but if you've encountered Kubernetes before, you will see a lot of YAML in that space. But the point's not really YAML. The point is taking a declarative approach and focusing on what users really want. Oftentimes when those declarative things are saved on disk, it is saved as a YAML file. But the point is not so much the YAML itself, but what it's describing. So what we're describing tries to be simple and letting the code handle most of the complexities of the wider system. So again, we're describing something in the small and letting the code take care of all the hard bits. While we were designing the system, we tried to take a few hints from the microservices trend. Very popular and also paired with Kubernetes. The key takeaway there is really that we're trying to break up certain tasks by component, keep components separate. So for us, that usually means running things in separate containers within the pod abstraction within Kubernetes. I will say that working with Samba in this space has been quite pleasant so far. Samba already does a pretty good job for this type of thing, specifically like the split between SMBD and winbind and the various tools. All right, moving on to more operator-specific things. Michael mentioned earlier that we have a new design around our custom resources. Referring back to the previous slide, this is all about focusing on what users want and not the implementation of what they want. So specifically, we went away from a server-oriented model to a purely share-oriented model. What that means is we've established 2 new custom resources, SMB Share and SMB Security Config. SMB Share is the resource the users will interact with the most. That is a direct representation of them asking for something to share. That takes 3 main parts. That is storage, backing up the share. That is done by either specifying a persistent volume claim that already exists by its name, or you can embed the entire PVC specification, which is a standard thing in Kubernetes, within our own custom resource. When you do that, our operator takes care of creating the PVC for you and life cycling it along with the share itself. We have a few basic parameters around SMB shares themselves. If you're familiar with smb.conf, you'll see what these are. Currently, we have stuff for the name, the read-only status of the share, and if it's browsable or not. Then the last piece is a reference by name to a SMB security config, and that defines how and what users can actually log into the share. So the SMB security config comes in two flavors. There's a users flavor, or users and groups. This is basically your standalone server. And currently it is configured by specifying a Kubernetes secret resource. And within that resource, you save a JSON document that has a representation of your users and your groups, along with their password or password hash. We also have our Active Directory flavor, which is totally new since Michael's demo last year. In that form, we have to specify a domain or realm. And then we have a mechanism to specify how to do an unattended domain join. Currently, we have one method for doing an unattended domain join. And similar to our users and groups, that is a username and password stored as JSON within a Kubernetes secret. Again, the big takeaway from this is we've kind of removed the focus on servers or server instances. Of course, we need them, but they're now moved to more of an implementation detail, defined and managed directly by the operator itself. So again, you're not saying, give me a server, give me a server. You're saying, give me a share and giving me a share and letting the system do most of the hard work.
John, if I make real quick chip in here, I want to highlight those, right? Especially the SMB security config aspect. That's more to be understood as a template for how a server can join a domain or provide users. It's not meant to be understood as a configuration of a concrete server, right? So it's really the operator will take care of the servers. Here's how security can be done, and this is how I can define the share. And then, that is the
excellent point.
If radically different and, in my mind, excitingly new way of doing Samba configuration.
Sure. If we have enough time in the demo, I'll at the end try to show how what that resulted in, if we have time. Okay, so wrapping up the last couple of slides, the workflow is roughly as follows. We have an operator running, it's a process running within Kubernetes, connected to the Kubernetes APIs. When our custom resources are changed, created, updated, whatever, our operator turns around and makes changes to native Kubernetes resources. These include, but are not limited to, persistent volume claims, deployments, and deployments is a kind of an abstraction around pods, and pods are what run the actual containers, and Kubernetes services, which is kind of the bridge between the local pod and the rest of the networking in the system. So once the operator has created our pods, pods execute containers, and containers are simply an abstraction around processes in Linux. We have containers that set up the basic environment. We have containers that join AD, unattended if possible. We have containers that will ultimately run the interesting Samba bits of the system, SMBD or Windbind, if we're AD enabled. All right, so that's a lot of talk. It's time to show you something in practice.
And while you're bringing this up, I want to just repeat or highlight that while it's the same container image that's doing these things, we are spawning different containers with different entry points for the various purposes.
Yep. Excuse me. Okay, so our prerequisites before the demo starts. What I have running in a cloud is one virtual machine running our container image of the Samba ADDC. So that's a Samba-based ADDC outside of Kubernetes. I have one Windows VM, which we'll use later in the demo, that's already joined to that domain. And then I have a small 3-node Kubernetes instance. Okay, so this is just deployed today. It has pretty much nothing in it. And this is a quick rundown of what namespaces are in Kubernetes. There's nothing interesting going on here. It's a pretty stock pre-install. So now I'm deploying our operator. This is a pretty young project, so we don't really have anything fancy like Helm or whatever. We just have the hacker's method of deployment, which is the make file. Okay. So now we're going to ask Kubernetes what are our namespaces, and you can see we have a new namespace, Samba Operator System. I'm going to use this system, this namespace for the rest of our Kubernetes commands. So we're just setting up a default here. All right, so excuse me. All right, so we have one pod running in our namespace. That is the Samba operator itself. For later steps in the demo, I'm going to want to use our SMB client image because it's a little bit easier to demonstrate things inside the cluster at the moment. So I'm going to deploy a new pod that has our SMB client in it. Okay, so now I'm just monitoring the progress of the pods within the cluster. Okay, so now we have 2 running pods, one for the operator and one for our test client. Okay, so the first thing we're going to do is I'm going to show a standalone instance. And first off, we're going to get to see the YAML files. Okay, so this is a concrete version of the slide you saw earlier. First off, we have our Kubernetes secret. And within that is our embedded JSON. We have a few users in here. Unfortunately, for time purposes, I did not use them in the later part of the demo, but this is a live thing. And then we have our SMB security config custom resource. This is not something that comes with Kubernetes. We have defined that. We have a name for user group security, and the body is very, very simple. It just simply says we're the user flavor and which secret to look at to get the content from. We're going to create one share. As you can see, the kind is SMB share. We have a name of first, and we have a share name of first share. Kubernetes name restrictions are much more strict than what you can do with the SMB share naming. So in this case, I've created a share name that has a space in it. We have our read-only and browsable flags, and we have our reference to our security config. Lastly, we have a embedded PVC specification where we request from the system, and we're not requesting any specific storage. It's just whatever default Kubernetes has in this case. We're asking for 1 gig of storage. Any quick questions before I move on? Okay. So now I'm going to install these resources in Kubernetes. Okay, that's the security config. And here comes the share. So now I'll monitor the progress of the pods in the cluster. Okay, so right now we have a pod created by Kubernetes. And currently we are still creating the container. Again, for those familiar with the container ecosystem, the containers are often downloaded before deployed or started from the container registry. So the initial startup can often take a little bit of time. Okay. See, it was a little longer today, so it was just long enough to start to make me nervous. But we do finally have our pod up and running. This indicator here is the number of containers within our pod and how many of them are ready. We have one container in this pod because it's a standalone server. There's pretty much just SMBD after the initialization has run. So now we can log into our share. I'm going to use the SMB client pod that I created before. So this is kind of equivalent to SSH and then running a command within that instance. Okay, I will point out that in this case, we have a DNS name based on Kubernetes' own internal DNS. And of course, the name of the share as we defined it in the SMB share YAML file. This is a newly created volume, so there's nothing on here, but I have a few test files already in the client pod. Okay, so I've managed to copy a few files to our share, logging out, and now I'm going to show you what it looks like from within the container itself. Okay. So as you can see, we have the two files that I just uploaded. We also have name to UID mapping working. So that's all I'm going to show today for standalone / users and groups. On to the more exciting bit, if you can call Active Directory exciting, joined member servers.
We always call Active Directory exciting.
Sure you would, Andrew.
I shouldn't say that with this audience. You're right. So we have, first off, we have our Active Directory-based security config. So once again, we have a secret here. But in this case, instead of defining the users and groups ourselves, we have a username and password that has the rights to join a system to the Active Directory. We have our SMB security config. Its name is AD Security. We have a mode of Active Directory. And unlike users groups, of course, we need to specify what realm to join. And we have one join source, which is the secret above. And we're referencing it by name. Oh, and I should mention that due to this architecture, the operator itself never sees the content of these secrets. Only the pods themselves see the content. So the operator is completely ignorant of the ADs themselves. And then in this case, we have two shares, AD share 1 So kind is SMB share. We have a share name, in this case, of archival data. Once again, I put a space in there for fun. In this case, we have our security config of AD security. The backing PVC is set up the same, but it is a different PVC. Lastly, we have one more SMB share. Pretty much all the same. In this case, it's named users with a share name of a capital U users. Okay. Now it's just a matter of putting these files in Kubernetes. Okay, with that done, the operator is processing the resource and probably has already created some pods, and we'll see. Yep. Okay, so we have our archive and our users. Currently, the pod is initializing, and that's a step where it runs one container from start to finish, and then it runs another. So that's the initialization or init container step. And after that, it starts to run the long-running containers. In this case, because we have Active Directory enabled, and it's going fast enough that it's making it hard to click. We have users. We currently have, this guy is still initializing, and it's finished down here. The point is that in this case, we have 4 of 4. That means we have 4 containers running within the pod. That's 1 SMBD, 1 Windbind, and 2 helper containers. And if you're curious what they actually do, ping me after the talk. Okay, so one more quick thing using SMB client. I'm just going to upload a few files into one of the shares. And this time, this is an AD user. Our domain is called domain1.sync.test. Okay, so I've logged into the share. Again, this is a new PVC. There's no new volume. There's nothing in it. Okay, we have 4 files in the share. All right, all this terminal stuff is boring. It's finally time to use this lovely Windows VM that I've been ignoring for the rest of the demo. As I mentioned, this is already joined to Active Directory. And so one of the things we've done is had the pods automatically register their IP addresses with the AD DNS. So I should be able to say users. Windows is quick. And there are the files that we just uploaded. To prove that it is an actual file. Yay. All right, and then for the other share, we have the name of archive. Never gives me a chance to type. So again, this was an empty volume. We didn't upload anything to this one. So I'll just quickly create something here. And that's pretty much the demo. Michael, how about a time check? Should I show anything else before returning to the slides?
We have 9 minutes, including questions, so maybe we should speed up.
Okay. In that case,
you could, of course, go into the container and show that this folder has been created, but I think that's fine.
I think that's covered in the other thing. I will mention, if you want, this is a working system, so if you're curious, ping me after. I'll leave this cluster up for like the rest of the day. Okay, back to the slides. All right, I won't talk much upon this slide again because we don't have a lot of extra time, but some of the things in the demo are not merged into our main repos yet. This kind of covers some of that stuff. At the bottom, there are some links. That is literally the exact code I'm using in the demo. The plan is to get everything upstreamed. Some things need a little design work first. So, okay, so Michael's talked about the past. I've talked about the present. It's time for us to talk a little bit about the future, what's coming up. In the short term, as I just mentioned, getting what's in the demo turned into something real so others, people who aren't me, can use it. Next, we've been moving pretty fast, and as a traditional thing for open source projects, we could use a lot better documentation. This is especially relevant as we have more people onboarding on our team, but I also want to make it so that others can at least understand what's going on. There are some rough edges still. Again, as other people are starting to poke and prod the projects, some of these are showing up more. That's all necessary stuff. We're also currently looking at turning the current internal metrics that Samba keeps, things like users logged in, the traditional stuff that SMB status provides, and exposing that through the Prometheus system. If you're not familiar with Prometheus, Prometheus is the kind of de facto standard for metrics in the cloud native space. The next two bullet points are closely related, and they have to do with our behavior around the migration of pod from node to node. In one case, we want to make sure all of our metadata, your things like your ACLs and permissions persist properly if the pod moves from one node to another. And more importantly, we have a lot of work ahead to do to deal with our failover story, our HA story. We're looking at both Kubernetes native tools as well as how we might integrate with something like CTDB. And Michael's going to elaborate on that in a moment. And then lastly, I just want to mention that, of course, testing is extremely important to us. We definitely need a lot more, but I'm happy to say we recently added a fairly decent test framework to our repos and are now able to do proper integration testing running with a small Kubernetes instance in our CI. And with that, I'm going to pass this back to Michael so he can discuss CTDB, failover, and other future-looking items.
Right.
Thank you.
Thanks, John. And the question about CTDB has also come up in chat already. So I want to quickly go, yes, we have started looking into it and considering it. But let's first look into what do we really need CTDB for, right? I mean, I haven't even mentioned here public IP, service management. We don't need it. Kubernetes does all that for us. Let's look at the core of CTDB. We basically need it for two purposes: high availability, failover mechanisms, and scaling out, right? So the failover, in theory and in principle, Kubernetes provides that, right? If some node is unavailable, it will take the service and bring it up on another node. It works in principle, but it may just take time. It may take time that it's too long for the expectations of the Samba clients. The other thing is making it safe with just Kubernetes mechanisms requires some form of fencing of the access to the backend storage. And so there's work to be done if you want to do it without CTDB. Scaling out is an interesting aspect, right? So scaling out in the sense of supporting more concurrent users on our shares, on our server. Remember that we have gone with a one-to-one correspondence SMB server and share. Well, this can be we are much more flexible than that in principle, but for now, this is what we have demonstrated. So more concurrent users can mean we have very, very many shares. And then per share, we have just a few users. So that's already covered by our container approach. We don't need CTDB for that. But what if we just have a few shares or just one share and we have a lot of users concurrently on that single share? There we might need CTDB. So the lesson learned here is CTDB might be needed or for a good or at least a better HA. CTDB might be needed for some use cases for scaling out, but not for all. So we can go quite far without CTDB. That's why we started like this. And another reason why we've avoided it just yet for the demo and so on is, apart from this, yes, we can, to some extent at least, and it results in a less complex system. The system is already complex enough with Kubernetes around it. And we all know, like, putting some cluster into and on top of another cluster is not trivial per se, but it's also CTDB setup and configuration is kind of a little bit delicate. There's the nodes file that's kind of static and needs to be very carefully maintained. So there's work to be done in order to properly bring CTDB into this like kind of volatile environment of Kubernetes. So how much would CTDB need to change in order to do this? So this is stuff that we're investigating, and this will come up in a lot of discussions. So next slide, please. I need to be a little more quick. So other goals, the middle and more long-term goals. Offline domain join. See, Günter's great talk. For those who haven't seen it, please watch the recording. That's really great stuff that will get rid of the need to have the password in that secret. Anti-ACL support. There's stuff to be done. Especially the security X-adder namespace that doesn't go well down with containers, and there are PRs for that. Tighter integration with backend storage like CFS and so on. How far can we get with a simple approach, just mounting the thing? Where do we need more integration? ID mapping. We just have a very opinionated, simple thing. Can we offer more choices? In general, more stuff that we expose. Vertical scaling. More than one share per server. The operator has all the decision-making power. The user shouldn't care much. And then different integration points. And then the test-only Active Directory server container that we have, we could also make that managed by the Samba operator for nice projects in Kubernetes and so on. Another point I don't even get into is we might move the whole Samba operator project under the Rook project, which is a well-known operator, one of the old operators that is managing Ceph, but also other system. It's part of the Cloud Native Computing Foundation like Kubernetes, so it's a good place, but it's a little early for that. So we are basically out of time, so let's quickly go to the next slides. Anti-ACL support was mentioned. We needed maybe improved decoupling between the processes. CTDB, we might need more flexibility and automation in setting up CTDB. I have a couple of ideas what we might do with dbwrap to better fit into the Kubernetes ecosystem. And for doing those jobs that, for instance, the Samba CC container configuration script does, APIs is better than CLI calls. So this is stuff. And real quick, I'm speeding up. For what is in it for Samba itself, right? I mean, it's a new ecosystem. It's new users, maybe new kind of users for Samba, different personas of admins, and OS distribution. OS agnostic distribution is also a good thing, right? It's decoupling a lot of things, and chance for more code cleanup and component segregation. I mean, that's just a couple of things come to mind. There are probably more, and with that, I think we are done. So sorry for taking all the time. More than happy to take questions in the other room.